Hello and welcome to the lesson video notes for Chapter 11, Lesson 1, Lines that Intersect Circles. Now, it's going to be important that we remember some things about lines in the coordinate plane for today's lesson. So, before we get into our objective, let's do these warm-up problems, writing the equation of each of these lines, and then solving for x, just a little algebra review and solving equations for x. Go ahead and take a few moments to complete this warm-up, and when you are ready, push play to continue watching the video. Alright, pause the video if you need more time, but otherwise these are the answers we should get. FG is a vertical line crossing the x-axis at -2, so the equation of that line is x equals -2. EH is a horizontal line that would eventually cross the y-axis at 3, so our equation is y equals 3. Alright, on example 3, if we solve for x, we get 18.25. On number 4, we get x equals 8. Alright, let's take a look at identifying tangents, secants, and chords, and then using properties of tangents to solve problems. These are all parts of lines that will intersect circles. Okay, first we need to look at what the interior of a circle is and what the exterior of a circle. Very basic. Interior of a circle is the set of all the points inside the circle. Exterior is the set of all the points outside the circle. So interior, exterior. Let's take a look at the new terms from this lesson. Again, these are things you should have filled in using your book already. If you need to pause to copy these down, that's okay, but I'm going to go right through these quickly. Lines and segments that intersect circles are broken up into 3 different categories. A chord is a segment whose endpoints lie on the circle. Remember, segments have a definite length. They stop at the endpoints. A secant is a line that intersects a circle at 2 points. So it's a line continuing in both directions. So if I were to extend the ends of a chord infinitely, I get a secant. And a tangent is a line that intersects the circle at exactly 1 point, only 1 point. It's like the circle is laying on that line at just 1 point. And that point is called the point of tangency. So in our next example, we are going to identify chords, secants, and tangents from the given diagrams. So in this example, let's do 1A together. I'm going to do 1A with you, and then you need to pause the video so you can do 1B. We are given circle L. We want to identify all of the segments and lines that apply to each of these names. Remember, chords are segments whose endpoints lie on the circle. Well, that could be segment KM. That's a chord. Even though JM is a line, it also has a segment, JM, as part of it, so I can call JM a chord. And those are the only chords we have. A tangent is a line that only intersects the circle once, and that would be line M. That's our tangent. Radii are any radius of our circle, starting at the center and having the other endpoint on the circle. Well, JL is a radius, KL is a radius, LM is a radius, and those are the only ones we have. A secant is a line that intersects a circle at 2 places, so that would be line JM. That is different than segment JM. This is a segment, this is a line. And a diameter is, and you should remember this, a segment whose endpoints are on the circle and goes through the center. The only diameter we have drawn is KM. Segment KM. Alright, when we talk about our tangent line, the point of tangency is the place where this line M intersects the circle. That's point H. Alright, why don't you try and identify chords, tangents, radii, secants, diameters, and points of tangency, for example 1B. Pause the video so you have enough time to do this. Alright, if you need more time, pause again, but otherwise these are the answers you should get. Alright, chords are QR and ST. Tangent is line UV. Radii are PQ, PS, and PT. Secant is ST, line ST. And the diameter is segment ST, and the point of tangency for our tangent is U. Alright, and we do have some other terms. Congruent circles are congruent if and only if they have congruent radii. So if the radius of circle A is the same as the radius of circle B in length, then they are congruent circles. Concentric circles are coplanar with the same center. Think of a bullseye. Coplanar circles that intersect at exactly one point are called tangent circles. We could have internally tangent circles where they intersect one inside the other, or externally tangent where they intersect one outside the other. So let's identify tangents of circles. Okay, we have tangent circles R and S. R and S. These would be considered externally tangent. And so here's what we need to do. We need to find the length of each radius. Well, this radius stretches up 2 units, so the radius of circle R is 2. The radius of circle S is 1.5, or 1.5. The point of tangency, we put these on the coordinate plane. We need to come up with the coordinates of the point where the two circles touch. That is the ordered pair -2, 0. The equation of a tangent line is the line that is tangent to both circles. Well, the line tangent to both circles would be the x-axis. And the equation for the x-axis is y = 0. All right, why don't you try example 2b on your own and pause the video, and when you're done, click play to check your answers. All right, here's what we should get. For circle A, the radius is 4. For circle B, the radius is 2. The point of tangency, where the two circles touch, is the point 3, 0. And the tangent line, since these are internally tangent, the tangent line is this line here that they've drawn for you, has the equation x = 3. All right, quickly moving along. We also want to talk about the idea of having a common tangent. A common tangent is a line that is tangent to two circles. Now, we could have internally common tangents or common internal tangents, like this line P here, or line Q, because they would intersect between the circles. Or we could have externally tangent, where they intersect outside of both circles. Okay, here's an easy way to remember this. Internal tangents have circles on either side of the line. External tangents have circles on the same side of the line. So L is an external tangent, P is an internal tangent, M is an external tangent, and Q is an internal tangent. And we have some theorems that help us identify parts of these tangents. Theorem 11.1.1. If a line is tangent to a circle, then it is perpendicular to the radius drawn to that point of tangency. So we have line L tangent to circle A at point B. So at point B we have a right angle. Radius AB and line L are perpendicular. Also, if a line is perpendicular to a radius, then it is tangent to the circle at that point. So this is just the converse of this first theorem. So if we are given radius CD is perpendicular to line M, then we know M is tangent to circle C. There is one more theorem we need to look at, and that's theorem 11.1.3. And this says if two segments are tangent to a circle from the same external point, so if we have what looks kind of like an ice cream cone here, then those two segments have to be congruent. If I have point A out here and I stretch point A to the top of circle B here and to the bottom, or to the top of circle P here at B and to the bottom of circle P at C, then AB and AC have to be congruent. So let's take a look at our last example. Example 3, here's what we are given, that HK and HG are tangent to circle F. Remember, that means these are congruent. So HG and HK are congruent. That means their lengths are equal. So we can plug in these and solve for A to find the actual length. HG is 4 plus 2A. HK is 5A minus 32. Why don't you solve that equation for A? Once you know what A equals, we can plug it back in to find HG. So go ahead and do the rest of this example. Pause the video so you have enough time. When you're ready, click play and we'll check our answer. Alright, this is what we should get. A is 12. So that means I can plug back in to find HG by doing 4 plus 2 times 12. 2 times 12 is 24. 4 plus 24 is 28 units. That's your answer for example 3. Alright, this concludes our lesson for 11.1. We will begin the assignment in class, but I've also attached it to the worksheet, so if you have any questions, go ahead and see me Monday in class.